Hello and welcome to this video. In this video we will study a bit of theory about hashing because that is the natural topic which we follow after graphs. I have not touched some problems in graph and I have proceeded to hashing because I want to finish hashing, and then we will do problems and I will include everything in that. For example, we have not covered red black trees or tries. We will include those data structures in the problems itself. Those will be titled coding interview questions, and we will solve many problems along the way and do some competitive programming. So if you are new to the channel, please make sure that you subscribe to the channel and press the bell icon so that you can get notifications about the upcoming videos on data structures and algorithms. Without further ado, let's get started. So first question is, what is hashing? Hashing is basically you take some input, pass it through a black box called hash function, and you get some output. Now with this output, you put that output and the original input into some table. So when you need to search for some value, you put that through the black box, get the key, locate the key in the table, and get the hash value. Key means hash value. Hash value you get and locate that hash value in the table and find the corresponding value. So essentially it is a search technique. Now the hashed value can be fixed length or variable. Some hash functions are of fixed length, some are of variable length. So this black box is a mathematical function which is called a hash function. The output of these hash function is called keys. The input is called value, and table where the keys and value are stored is called the hash table. So the main purpose is to perform a fast search. We want O1, that is constant time search. Most of the trees give you order of log n. Even red black tree will give you order of log n. But it is very difficult to find a hash function. For example, if you consider 29 most popular words of the digit A and R as and so on, if you want which can transform this between 10 and 28 38, this should be 38, then we will need 39 table locations to store the 29 keys. Now it's very hard because 39 to the power 29 is 10 to the power 46 possible functions are there, and from a 29 value into 39 value set, only 39 factorial by 10 factorial, that is 10 to the power 39, will give distinct value for each argument. Rest will give you duplicate values. Now when we find duplicate values, that is, for example, consider this. Given an integer, we find mod 5 of that. So mod 5 is a hash function. But suppose we pass 1, the hash is 1, we pass 2, hash is 2, 3, 4, 5, 5 will 0, and after 6, it will start repeating. The hash will be 1 again, which will collide with the hash value of 1. So this collision worsens the search because when you are performing the search, you are not getting the value which you desire. So the additional lookup has to be there. There are techniques to avoid collision, but those techniques worsen the search time. So search time no longer remains order 1. Related to this is a birthday paradox, which says if 23 people are present in a room, then there is bound to be 2 people having the same birthday. If we select a random function that maps 23 keys into a table size of 365, the probability that no 2 key maps to same location is only 0.4927. So there is 50% chance that 2 people will have same birthday, according to this paradox. Now the problem of finding good hash function is so bad that if you program in C++, then the map of C++ backend is a red black tree, which is O log n. Now if you go through the ECC documentation, it says that no matter what hash function you choose, there will be collisions, and the collision will worsen the search time to order log n. So with a large data set, when you have lots of values in the hash table, even though we desire O1, it never happens. It goes down to O log n. Now there are certain desirable qualities of a hash function. First is it should be efficient to compute. so that insertion in hash table is easy and lookup is also easy. The key should be uniformly distributed. There should be minimum collision, that is high periodicity. When different inputs produce same value, it is called a collision. Number of items in the table divided by the size of table, that is load factor, should be low. Now we discuss some hash functions which are trivial at best. These are simple hash functions which we are going to discuss. One is called division method. So you take a modulus m. So m is the hash table size, and a prime number for m is suitable because it makes the distribution even. If you take a composite number, then the distribution will not be even. But consecutive keys map to consecutive location. That's a downside of this method. In middle square method, we take the key x and m digit middle digit from the square. So you square it. For example, you take 40, you square it. 40 square is 1600, so you take the middle digit 60. The benefit is that result is not dominated by distribution of top and bottom digits. However, the size of key and collisions are limitations of the problem. Digit folding method. In this method, we divide the key x into parts x1, x2 up to xn, where each part has the same number of digits except for the last part that can have less digits from the other parts. And finally, you add the parts to get the hash value. And in multiplication method, you choose a constant a between 0 and 1, multiply the key with a, extract the fractional part, multiply the result with them, and take floor of the result. So these are 4 simple techniques, arithmetic techniques to find hash functions. There are very popular standard hash algorithms like SHA-128, SHA-256, SHA-384, SHA-512, MD5, Murmur hashing. You have PBKDF, you have Bcrypt, Scrypt, then Argon 2, Blake 2. So there are lots of hash functions already available, which gives some of them are very good for a quite large data set. So we will study those little by little as we progress in theory and go through problems. I don't know when I will be cover the theory of the hash functions, which I named just now. So I'll stop this video here, and we will take a practical approach rather than a theoretical approach. We will not cover a lot of theory, but rather we will write code, because that's how I like to discuss the topics in data structure and algorithms. Theory can be quite boring, and it is essential, but it can be boring. Particularly hash functions is quite mathematical in nature, much like cryptography. A lot of uses of hash functions comes in cryptography. So we will slowly and gently go through this, and we will solve more problems on hashing, and hash related problems we will solve, and then I will continue on to coding interview questions. So if you find this video useful and informative, please subscribe to the channel, like the video, share it on social media, and make use of the comment to speak your mind, and let's interact in the comment box. Thanks a lot for watching. Happy programming.